Hello, this is the topic we are going to present memory organization and random access memory. The figure shows a conceptual arrangement of a multi-level memory system in a computer. It starts from a register file and then cache level 1, level 2, main memory and secondary memory. CPU registers are used for temporary storage of information and data in CPU. A capacity of 32 data words is a typical of register file, and each register can be accessed within a single clock cycle. Main memory. Large, fast, external memory stores program and data that are active in use. Storage locations in main memory are addressed directly by CPU load and store instructions. The capacity of main memory is about 1 to 2 power 10 megabytes. Secondary memory. These are larger in storage capacity but slower than main memory. It stores system programs, large data files, and it also acts as overflow memory. Some examples are magnetic hard disks and CD-ROMs. Cache memory. These are the smallest and fastest memory in a CPU memory organization. A cache storage capacity is much less than main memory, but it is much faster than main memory. Let us see some device characteristics. First characteristic is of performance and cost. The figure shows the plot between access time and cost in dollars. Let C be the price in dollars and S be the storage capacity. Then the cost is given by C by S. The basic performance measure is the average time to read a fixed amount of information. This parameter is called read access time. Then the second characteristic is of access modes. If storage locations can be accessed in any order and in any time without independent of location being accessed, the memory is termed as random access memory. If storage locations can be only accessed in a predetermined sequence, then it is called serial access memory. Then the third characteristic is of memory retention. Memories whose contents can be altered online, even if they can be altered at all, are called read-only memories. These are permanent storage device or non-erasable storage device. Memories in which reading or writing can be done with impunity online are called read-write memories. These are temporary storage purposes. Memories in which the method of reading destroys the stored information are called destructive readout memories. It is represented by DRO. Memories in which reading doesn't affect the stored data are called non-destructive readout memories. It is represented by NDRO. Other characteristics are of bandwidth and reliability. Bandwidth represents the maximum amount of information that can be transferred to a memory or from a memory per unit time. It is represented by BM and it is measured in terms of words per second. Reliability represents the ease by which we can access a memory. For example, memories without moving parts have higher reliability than memories with moving parts. Error detecting and error checking codes increase the reliability. Now we can see about random access memories. The figure shows a one-dimensional random access memory unit. First, the address is given through the address bus, which is represented by M, and the address decoder decodes the given address and selects a particular location from which the information is read or to which the information is going to be written. And then this shows a two-dimensional RAM unit. In one-dimensional RAM, it consists of a single column and a number of rows, but here the storage cell consists of an array of memories. The address is given to the address bus, and then the row address decoder and column address decoder selects a particular memory location, and then it is accessed. These two figures shows, the first one shows static RAM and the second one shows dynamic RAM. As we are seeing, static RAM has more number of transistors and complex in construction, but a dynamic RAM consists of a single transistor and a single capacitor. For SRAM and DRAM, both bipolar and MOS transistor circuits can be used. Generally, it falls into two categories, SRAM and DRAM. Static RAM resembles a flip-flop and it can store information permanently without any need of refreshing the cells. But in dynamic RAM, the 0 and 1 states correspond to the absence or presence of stored charge in the capacitor, which is being controlled by a transistor as shown in figure. In dynamic RAMs, constant refreshing is needed in order to store the data, since the storage charge in capacitor charges and discharges with respect to time. Difference between dynamic RAM and static RAM. Static RAM are faster, cost is high, refreshing is not at all needed, and then it is larger in size due to more number of transistors used. But a dynamic RAM, it takes higher access time than static RAM, but lower in cost. Constant refreshing is required since it is a type of destructive readout memory, and smaller in size since only one transistor is used.